Welcome to Macrohard. This is an operating system created by Quinn Schaffer, Alex Myers, John Kurian, and Alex Goebel. This operating system is created for our CSSE332 operating systems class at the Rose-Hulman Institute of Technology. This operating system is written in base C, without including any C libraries. It communicates with memory directly and works very close to the hardware itself. Currently, you see our shell running. Our shell is called by our kernel in order to take commands. These commands need functionality provided by the kernel and use interrupts to do so. These are the current commands implemented for our operating system. First command we'll look at will be reading a file via type. Our operating system uses a file system, which involves a directory to list the files currently inside memory and a map to record which sectors are filled by these files. Of course, in addition to reading files, being able to create files will also be useful. We will create a simple text file. Just like the other file, this file can also be read. This is done via interrupts. When create is made, it calls an interrupt to our kernel in which write file is called, which will make sure there's enough empty sectors to fit the entire file, write the data written into the command to those sectors, and then save the file onto the directory. Now we will view a directory. These are the current files we currently have in memory. As you can see in our directory, it lists the sizes of each file. This is computed by reading through the directory, figuring out which sectors are filled, and then converting this number into a character to print out to the screen. One may also want to copy a file. We will copy the file we created text into a new file called copy. As you can see, the message inside text is also inside copy now. Both are listed in the directory. We can also delete a file. We'll delete our original file. As you can see, it is no longer inside the directory. Its copy still remains, and its copy can be read. Of course, you cannot delete files that do not exist. As you can see, the directory has remained unchanged. In addition to writing, copying, deleting text files, one may also want to execute programs on a computer. Currently, our operating system can operate programs concurrently. We do this by having up to 8 PIDs. Each program that you want to run can be given a PID, and by using a round-robin technique, a timer interrupt will be called, and will save the current running process, find another process that's currently active, and run that process until, of course, that process terminates, or the timer interrupt occurs again, in which the round-robin process will continue again. As the current process will be put in the bottom of the queue, and the top of the queue process will then be running. In addition to running programs, we can also kill them. This program prints hello multiple times. We're going to kill it. I typed in kill 1. This process was given PID 1, and by typing kill 1, you're going to set it to inactive, so when the timer interrupt is called, it appears that this process is inactive and then will never be run again. In addition to normal execute, we also put functionality for execute foreground. The difference, as you will see, is if I run execute foreground on the program I just ran, it cannot be killed by its calling program. In this case, which is the shell. So the shell called exec foreground to run PLO and cannot kill it because it is being blocked. There is a program that we made called pwait2. pwait2 will use exec foreground to call fel2. It will, of course, then have to wait for fel2 to terminate. So fel2 would not stop running, or pwait2 will not stop running until fel2 finishes. This can be shown by executing pwait2 and then killing fel2. As you can see, it ended much quicker because it is waiting for fel2 to finish, and since it was killed to shell, which is not blocked, fel2 was dead, and then pwait2 was no longer being blocked and could finish. Of course, we also implemented additional functionality to our operating system. One example is Keller. Users have the ability to change both the text color and the background color of their screen. Even some fancy blinking colors. Now I'm going to demonstrate that memory is in fact safe. If the computer was to close down, and then be reopened, the files, as you can see, copy and macro, are still there at the bottom of the directory. Well, I hope you enjoyed this presentation on Macrohard. Goodbye.